Hello everyone, today we'll go for the next method, that is binomial distribution in your discrete distributions. Till now we have studied Bernoulli's trial and Bernoulli's distribution. This is binomial distribution. What do you mean by binomial distribution? In the same way as a Bernoulli's trial, we have a binomial trials also. If we have n number of binomial trials, among that the random variable has to just find out the number of successes among n binomial trials. To do this and to denote this success in n binomial trials, we use a binomial distribution. Here the binomial distribution is given by p of x is equals to nx, p power x and q power n minus x. X will be equal to 0 to n, okay, and 0 otherwise. What is this nx? Is if you write this nx, then it should be written as n factorial divided by x factorial into n minus x factorial. Okay, this is NCR. This is the way of writing the NCR. This is one more way of writing NCR. This is the binomial distribution. Okay, here x is the success and n minus x, what we are taking, is the failure. For example, if I take 100% means among those 100%, the trial is 30% success, means p, that is x denotes 30 and n minus x denotes 70. That is success is x and failure is n minus x. So I'll write p power x into q power n minus x. You can say p is the success rate and q is the failure rate also. And q is equals to 1 minus p, you can write. Okay, see here. And after this one you have to just find out the mean and the variance. Here, as in the here itself we have discussed, it is number of success in n binomial trials, is it not? For example, p is the success rate and f is the failure rate, means it is p plus p. If it is completely it is success, means p plus p plus p plus, like that I'll take. That is n number of p's I'll take, is it not? If it is means that is the mean. Mean means we'll take only the success rate. Variance means here we'll take the success rate at the failure rate. That is failure or success. Failure or success it may be. So it is n, p, q. That is variance. Now let me take the problem for this one. Okay. See, a production process manufactures computer chips on the average at 2% non-conforming. Non-conforming means it is the defected pieces. Okay, every day a random sample of size 50 is taken from the process. If the sample contains more than 2 non-conforming chips, the process will be stopped. Compute the probability that the process is stopped by the sampling scheme. What is the meaning of this? A production process is manufacturing the computer chips. Okay, on average daily, that is every day, 2% of the chips will be defective. Okay, likewise every day it will take 50, means sample size of 50 it will take. If the defective chips are more than 2%, then you have to stop the process. Okay, so you have to find out the probability that the process is stopped by the sampling scheme. You have to just find out the probability. Here you have to just go for binomial distribution. Okay, why we have to go for binomial distribution? See here, 50 we will take it as n number of chips will be taken. Among those n chips, 2% is the failure rate. But here, what is the success rate? You have to just find out. Out of n binomial trials, you have to find out the number of success. That is your binomial distribution. So here also you have to just find out 2% is the defective piece, means what is the success rate, you have to just find out. Now we'll go for the solution. Yes, in the solution, first given the sampling process consists of n is equals to 50 Bernoulli's trials. I have just told you it is 50 size 50 they have given, each with p is equals to 0.02. Okay, let the total number of defective chips in the sample X as a binomial distribution. This is the binomial distribution we have taken. So here we have find out n is equals to 50. So I'll just take 50. If P is equals to 0.02, that is 2% or non-confronting, it is non-defective, that is 0.02, and then 0.02 or non-defective means then 0.98 obviously is the defective pieces, is it not? So it is power x 50 minus x value we don't know, we have to find out x value. The probability that more than 2 defective chips are found in a sample, that is P of x greater than 2. We know P is equals to 1 minus P, that is 1 minus P x less than equal to 2. We have to just find out the probability for x less than equal to 2 first. We have to calculate this. So what I'll do, I'll take summation x is equals to 0 to 2. Because we have to find out x less than equal to 2, for the same formula I'll just take summation x is equals to 0 to 2. So what you have to do in each and every step for x value 0, 1 and 2 you have to check. See, if x is equals to 0 means here what you will get 0.98, that is x is equals to 0 I'll take, plus 0.02 power 1, it is what x is equals to 1 I am taking, plus it is plus, okay, then 0.02 power 1, 0.98 power 50 minus 1, that is 49, okay, into 50, this one x 51 if you take mean 50 and 50 C1 if you take means it is 50 only, plus NCR, that is 50 C2, x value is 2 now, I'll get 1225, 0.02 x value is 2, I'll take 2, then 50 minus 2 is 48. If you calculate this one, P less than equal to 2, that is probability which is having less than 2 defective chips is 0.92. Okay, now you have to find out the probability that more than 2 defective chips are found, that is P of x greater than 2. Fine. P of x greater than 2 is 1 minus P less than equal to 2. Already we have just find out the P of x less than equal to 2, that is 1 minus 0.92. So P x greater than 2 is 0.08. That is the probability that more than defective chips are found is 0.08. The probability that less than 2% chips is 0.92. More is 0.08. Now you have to find out the mean and the variance for this. U of x is equals to NP. N value is given 50, 0.02 is P. Then P and Q. P is 0.02 means obviously Q is 0.98. Then variance is 0.98. This is how you have to just find out the binomial distribution for the given problem. Okay. And the next topic is geometric distribution and negative binomial distribution. First we'll see what is this geometric distribution. Already in the last chapter we have seen this geometric distribution, right? Is it not? This geometric distribution is always related to a sequence of Bernoulli's trials. Okay, here let x is the number of trials to achieve the first success in a sequence of Bernoulli's trials. What is the meaning of this? X is the random number. We have a sequence of random numbers. In that, it is what? To achieve the first success in a sequence of Bernoulli's trial. For example, if I have n number of Bernoulli's trials means, see here, till n minus 1 it may be a failure but it is the success. Okay, or here from, see for example, I'll be taking 1, 2, 3, 4, 5, 6 till n I'll take. Here 1 is failure, 2 is failure, 3 is failure, 4 is failure, but 5 is success. This is the first success I have find out. This is, for this one you have to just use the geometric distribution. Okay, x is the number of trials to achieve the first success in a Bernoulli's trial. Okay, yes, first success. If you get first success, then you have to just represent it using geometric distribution. To represent the first success, we use the geometric distribution. So what is the formula for geometric distribution? P of x is equals to q power x minus 1 into p, where x is 1, 2, 3 till n. Okay, here the event x is equals to x occurs when there are x minus 1 failures followed by a success, because here you have to just find out the first success. So if it is x minus 1 failures, then one success has to be there. So each failure has probability q is equals to 1 minus p, and each success has probability p, because we will take only the first success, so it is just a p. If you have p numbers, means p is the success, then obviously 1 minus p is the failure. So we will take q is equals to 1 minus p, and then probability of success is p. The same thing we are representing here. See, if complete thing is a failure, but last one if it is a success, then also you can have a geometric distribution q power x minus 1 into p, because you have to find out the first success. That's it. After that, no need to bother for anything. Just if you find first success, then you can go for geometric distribution. And mean e of x is equals to 1 by p, and variance v of x is equals to q divided by p square. Okay, now first we'll see what is negative binomial distribution, and then we'll go for the problem, because we have to combine both of this to solve the problem: geometric distribution and the negative binomial distribution. Why we use the binomial distribution? Just now we have studied, is it not, binomial distribution. For what you will use this binomial distribution? In order to just denote the number of success in n binomial trials, we will use this binomial distribution. But what is the necessity of using negative binomial distribution? Okay, it is the distribution of number of trials until the kth success, for k is equals to 1, 2 till n. Okay, what do you mean by this? It is the distribution of number of trials until the kth success. There we were taking the number of success, that's it. This is until the kth success, means how many success you have, that one. Until that kth success you have to just go, then that is called as your negative binomial distribution. If here y as a negative binomial distribution with parameters p and k, why we are taking k? Here k is the kth success. Okay, its distribution is p of y is equals to y minus 1, k minus 1, q power y minus k into p power k. Okay, and mean is k divided by p, and v of x is kq divided by p square. See, here this is same, one and the same here, but it is similar, not the same. Okay, here the first success will take, so 1 divided by p and q divided by p square. But here we will take until the kth success, so we have to add the variable k for this one. So mean is k by p and kq by p square. Okay, now let me take the problem on this one. See, problem: 40% of the assembled inkjet printers are rejected at the inspection station. Find the probability that the first acceptable inkjet printer is the third one inspected. Also find the probability that the third inspected printer is the second acceptable printer. See here, both the things are there. Geometric distribution is also there and negative binomial distribution is also there here. See, 40% inkjet printers are rejected because we consider it as a failure piece and will reject it at the inspection station. First, find the probability that the first acceptable inkjet printer is the third one inspected. First acceptable inkjet, this is geometric distribution, because you have to just take only the first success. So first acceptable inkjet printer is the third one inspected. First one they have inspected, second one they have inspected, third one they have inspected, but the third one is the first acceptable one. So this is geometric distribution. Okay, for this one you have to use geometric distribution. Also find the probability that the third inspected printer is the second acceptable printer. Second acceptable printer means you have to go for the binomial, negative binomial distribution, because the kth success Okay, for example, kth in the sense second success, third success, or the fourth success, that depends. For that purpose, we have just mentioned it as kth success, that is second, third, fourth, or anything. First success is the geometric distribution. After first, the kth success is the negative binomial. It may be second, third, fourth, or nth. Okay, so this is negative binomial distribution. You have to find both geometric and negative binomial distribution. Now, let me come for the solution. Consider each inspection as a Bernoulli's trail with Q is equals to 0.4 and P is equals to 0.6. So why I have taken Q is equals to 0.4 and P is equals to 0.6. In the question they have given 40% are rejected. Failure will take in terms of Q. Success will take in terms of P. So here 0.4% is rejected, failure. Then remaining is 0.6, that is P. Okay, so P of x is equals to Q bar x minus 1 into P. I have just told you, you have to take the geometric distribution. The first acceptable printer is the third inspected, so P of 3. Okay, x is equals to 3, I'll take. Third one is the first acceptable, so I'll take P of 3. So Q power 3 minus 1 into P, you know the Q and P value, 0.4 whole square into 0.6, that P of 3 is equals to 0.096. This is the probability of accepting the third printer as the first one. Okay, then to determine the probability that third printer inspected is the second acceptable printer. Here also again the third printer inspected is the second acceptable printer. We use negative binomial distribution because it is kth. Second means you cannot go for geometric, you have to go for binomial kth. After first success, always it is everything, it is negative binomial. So P of 3 is equals to, what is the formula for that one? Y minus 1 to K minus 1, Q power Y minus K into P power K. So this is P of 3 is equals to 3 minus 1, 2 minus 1, 0.4 whole power 3 minus 2. Okay, here P of Y it is. So Y value is 3. Okay. Here Y is equals to 3 because here P of Y we are using. Y minus K. Why we are taking K is equals to 2? See here, kth, second acceptable. Second acceptable means K is equals to 2. Okay, because second one we are accepting here. So K is equals to 2 into 0.6 power 2. Okay, P of 3 is equals to 0.6 whole square into 0.4, 2, 1. 3 minus 1 is 2, 1. This one, how you will do? 2 factorial divided by 1 factorial into 2 minus 1 factorial. Okay, NCR formula. So P of 3 you will get it as 0.288. This is how you have to just calculate the geometric distribution and the negative binomial distribution. Okay, if it is first, only first success, it is geometric. If it is nth, then it is negative binomial distribution. Okay, yes, next we'll go for one more, that is Poisson distribution. Even this Poisson distribution also you have studied, is it not? Here this Poisson distribution describes many of the random process very easily compared to other distributions because it is mathematically very simple compared to other distributions. Okay, because only the basic mathematical functions will use in probability in Poisson distribution. So this will be considered as quite easy process for the random process in order to find out the random variables. This is a Poisson probability mass function which is given as e power minus alpha into alpha power x divided by x factorial. It is very easy, is it not? E power minus alpha, directly you can just find out, and alpha value will be given, directly you can just find out. So we can tell this is mathematically very easy. This is the probability mass function and this is the your continuous distribution function. C of x, so I is equals to 0 to x e power minus alpha into alpha power I divided by I factorial. Here always you have to take alpha is greater than 1. Okay, And mean and variance is alpha. Alpha will be considered as mean and variance for this Poisson distribution. Next we'll go for the problem. Here a computer repair person is beeped each time if there is a call for service. If any customers enter for the service, then he'll get a beep sound. Okay. The number of beeps per hour is known to occur in accordance with Poisson distribution with mean of alpha is equals to 2 per hour. Okay, means 2 beeps per hour, that is alpha, mean alpha is equals to 2. Find the probability of 3 beeps in the next hour. Till here, for every hour he is getting 2 beeps, but you have to find out in the next hour 3 beeps is going to happen. That probability you have to find out. Also find the probability of 2 or more beeps in 1 hour. Okay, so alpha is given, alpha is equals to 2. So probability of 3 beeps in next hour means here what you have to do, p of x, that is p of 3, x value is 3 here, beep value, x is equals to 3, e power minus 2, that is alpha value 2 power 3, 3 factorial. Okay, or else you can just take it as f of 3 minus f of 2. With this formula means you have to take it as f of 2 minus f of 1, because previously we have just seen p of 3, that is f of 3 is equals to f of 2 minus f of 1. Okay, so f of 3 minus f of 2. This is easy, you can just go with this one. Then probability of 2 or more beeps in 1 hour on our 1 hour period. P of 2 or more beeps, that is in 1 hour. This is 1 hour I am taking, minus p of 0 minus p of 1 I have to take, more than 2 or more. Okay, so p of 0 minus p of 1. In the same way you have to find out p of 0, then p of 1. That is p of 0 means x is equals to 0, then p of 1 means x is equals to 1. Then this is the answer you will get for p2 or more, 0.594. Okay, in the next class we'll go with continuous distributions. For this we'll be done with the discrete distributions. Okay, thank you.